Hi everyone, and we are back in section 2 for the Maintaining Air Quality chapter. So in section 2, we will learn about air pollutants. We previously learned about the composition of clean air. So now we look at what is found in polluted air. Right? In section 2a, we will focus mainly on the sources and the effects. And then in section 2b, we will focus more on the removal. So let's take a look at our notes. Okay, first, air pollution is actually the presence of harmful substances, and it must actually cause harm to human health. So we must take note, let's put a special note here, that carbon dioxide is not considered an air pollutant because there is no harm of carbon dioxide on human health. So we must remember that carbon dioxide, while it's a greenhouse gas and it will lead to global warming, and the global warming might eventually lead to human health detriments, but carbon dioxide itself is not harmful to human health. Right, so let's take a look at what are the air pollutants that you need to know. So just a quick summary. First, we have carbon monoxide, CO, sulfur dioxide, SO2, oxides of nitrogen, NO, nitrogen monoxide, NO2, nitrogen dioxide, and NOx, where X can be any number. We have methane. We have unburnt hydrocarbons. We have learned that hydrocarbons are organic compounds that contain only carbon and hydrogen atoms. And finally, we have ozone. Now, ozone is very interesting because ozone is a pollutant in the lower atmosphere, that means nearer to us, but in the higher atmosphere, ozone is actually protecting us. Okay, let's look at the sources of all these pollutants. So first, we have carbon monoxide. So carbon monoxide source is the incomplete combustion. The word here is incomplete combustion of carbon-containing fuels. So if the fuel doesn't contain carbon, it can't produce carbon monoxide. So it must be incomplete combustion of carbon-containing fuels. In the urban area, that means in the town, in Singapore, the main source of carbon monoxide will therefore be in cars, right? Cars that burn petrol. So if there's incomplete combustion in the car, that means there'll be a lot of carbon monoxide being produced. Now, what type of harm can carbon monoxide produce? So carbon monoxide firstly is described as toxic. So this is the word that's given in your syllabus. Carbon monoxide is described as toxic. When we say a gas is toxic, you can almost confirm that it's going to be carbon monoxide. So why is it toxic? It's because carbon monoxide reduces blood's ability to transport oxygen. So over here, the terms, just remember it exactly, right? And do not adjust it accordingly. So either toxic or reduce blood's ability to transport oxygen. Next, we have sulfur dioxide, SO2. So sulfur dioxide have a man-made source, that means by humans, and a natural source, that means no humans involved. So man-made source is when we combust fossil fuels. A lot of fossil fuels contain a little bit of sulfur because it comes from underground. So when we combust the fossil fuels, we will produce sulfur dioxide. Right? The natural source is volcanic eruption or volcanic activity. Right? As long as there is a volcano, there will be sulfur dioxide coming out from there. Right? Before we talk about the effects, let's talk about the next one, which is the oxides of nitrogen. Now, the oxides of nitrogen is actually very interesting. It is actually formed in the same way. Right? It's always formed when atmospheric nitrogen, which is nitrogen in the air, reacts with atmospheric oxygen, which is oxygen in the air. Nitrogen, as you know, is N triple bond, so it's a very strong bond, and oxygen is O double bond O, so it's also very strong. So that means we need to have situations where there's high amount of energy for us to actually break the N triple bond as well as the O double bond for the nitrogen oxides to form. So where does this high energy come from? So the man-made source of this high energy comes from internal combustion engines, or what you will know as ICE engines, internal combustion engines. These are actually the engines found in most cars, most vehicles. And it is this high temperature in this engine that gives enough energy for the nitrogen and the oxygen to react together. So again, the car engine gets hot, and it's not because of the petrol or the fuel, but because the engine is hot, it causes the nitrogen and oxygen in the air to react. It is not the engine reacting, it is not the petrol reacting, but it is the atmospheric nitrogen and oxygen reacting due to the high temperature in the internal combustion engine. So the next one is the natural source. So the natural source of oxides of nitrogen would be lightning activity. So lightning activity, when there's a lightning strike, there's a lot of energy. And when there's so much energy, the nitrogen triple bond will be broken, the oxygen double bond will be broken, and it will react together. Right? So take note that lightning activity is different from thunder. Thunder is the sound, and thunder doesn't cause the nitrogen triple bond to break. It is the lightning. So it must be lightning activity. Now, both sulfur dioxide and oxides of nitrogen have the same harm to human health. Firstly, it causes breathing difficulties. Sometimes you will see it as respiratory difficulties in certain papers, in certain years. So in chemistry, we are not very particular the difference in breathing and respiration. So over here, you will see it used interchangeably. So breathing difficulties and respiratory difficulties. Right? Next, because sulfur dioxide SO2 and nitrogen dioxide NO2 are acidic oxides, they are non-metal oxides, they will actually cause acid rain. And acid rain, acid will react with our MAC. M stands for metal, A alkali, and C carbonate. So any metal structures will react with the acid rain, and any carbonate, which is like limestone, will also react with acid rain. And we also know that the soil will become more acidic with acid rain. Let's move on to the next few. Next, methane has become a little bit more popular in pollution, right? So methane is actually two things. It's not only a pollutant, it is also a greenhouse gas. So these two things at one time. So methane as a pollutant formed in agriculture and farming. They will like to call it your cow farts. So whenever your cow farts, a lot of methane is being produced. So we'll write agriculture and farming. And when we throw a lot of trash in your landfills, because of decomposition of your trash, it will also form a lot of methane. Lastly, there's an increased use in natural gas, and you have learned in the previous chapter that 95% or more of natural gas is actually methane. So when natural gas leaks, methane is leaked. However, I would like you all to keep to number 1 and number 2 as a source of methane. Now, the effects of methane, you don't really need to know. Now, for unburnt hydrocarbons and ozone, I think you can just have a quick read. And this can be a bit of general knowledge about the sources and the effects of unburnt hydrocarbons and ozone. Right, let's move on to the effect of acid rain before we do some practice. Right, so acid rain is due to the pollutant sulfur dioxide and nitrogen dioxide because they are acidic oxides, and not nitrogen monoxide. You must recall that no cold water, NO, nitrogen monoxide, CO, carbon monoxide, and water, these are our neutral oxides. So because neutral oxides dissolve in water to form neutral solutions, neutral oxides don't form acid rain. Now, sulfur dioxide, when it goes into the atmosphere, it will react with oxygen and water vapor to either form sulfuric acid or sulfurous acid. So we have equation 1 and equation 2 over here, sulfuric acid and sulfurous acid. I just want to remind you all that this is not explicitly needed. Next, nitrogen dioxide also reacts with oxygen and water to form nitric acid. Again, the reaction is also not explicitly needed. If we want to test you, we will probably give you the equation and ask you to describe maybe redox or something like that. Finally, we know that acid will react with MAC, so it will react with your limestone, which is a carbonate. It will react with your metal buildings, your metal structures, your lampposts, your bridges. And finally, your vegetation, the soil might get too acidic, and we have learned in acid and base that you need to add calcium hydroxide to increase the pH of the soil. Right, so that's it for this particular part of the chapter. We will practice some questions in the next video. Right, bye.